Good afternoon, everyone. Today I would like to talk about the dehydration of alcohol to alkene, and this is one of the example. 3-dimethyl-2-butanol, it will react with the concentrated sulfuric acid and will form back to the alkene, which is the 2,3-dimethyl-2-butane, and the byproduct is H2O. Let's proceed to the step 1, which is protonation of OH group. To simplify, when the 3-dimethyl-2-butanol react with the H2SO4 here, the hydroxyl group here get a proton H plus from the H2SO4. This happens because oxygen in the hydroxyl group is more attracted to the proton here due to the electronegativity difference, and the H2SO4 molecule help transfer the proton and making the hydrogen atom in it electrophilic, or we call it partial positive charge, and attracting electron from the hydroxyl group, which is nucleophile. The oxygen here in 3-dimethyl-2-butanol being electron rich, it get the hydrogen from the OH in the H2SO4. Why the oxygen here can attach to the hydrogen here? It is because oxygen have two lone pair, and it use one of its lone pair to attack the hydrogen atom. And this causes the bond between the hydrogen and the oxygen in the H2SO4 is breaking down. And then the electron here will move toward the oxygen because it is more electronegative. And here we see the intermediate product here. It will produce protonated alcohol. This protonation step is important because it changes the OH group here into a beta leaving group, or we say that it is setting the stage for the elimination reaction. And after the atom H here attached with the OH here, it will form H2O, right? So after it forming H2O, it will remove from this molecule from this, while at the same time the OSO3H ion is created because of the H2SO4 is lost a proton. Alright, now we will proceed to the second step, which is formation of carbon cation by removing the H2O. In this step, as we discussed in step 1, they will form a H2O because the H atom and in the H2SO4 is attached with the OH group. So the H2O here is removed to breaking down the CO bond here, and the two electrons from the bond here will move toward the oxygen with the same reason, because oxygen is more electronegative than carbon. And we saw here the intermediate product here. After removing the H2O, this will form a secondary carbon cation. And the step 3 is rearrangement. In the carbon cation intermediate, a nearby H atom, we see here there is two methyl group here, but the carbon cation here only secondary carbon cation. It need become more stable, so it will change place with the methyl group here, which is undergo 1,2 methyl shift. These two will change their position at the same time. So after 1,2 methyl shift, A more stable carbon cation is formed, which is tertiary carbon cation. This rearrangement creates a more stable and substitute carbon cation, which it can making the reaction more efficient and selective. Now we proceed to the step 4, which is deprotonation, or we call it loss of proton. In this step, the OSO3H will act as a base, which it will grabbing the nearly H atom, and this is the hidden H atom, which is next to the tertiary carbon cation here. And this follow the rules we call success rule. It lead to a more stable 2,3-dimethyl-butane to become major product. And in this reaction, the sigma bond between the CH here will break, and the 2 electrons will shift between the C atom and the tertiary carbon here to form a pi bond, which will form a carbon double bond. And we see here the final product, 2,3-dimethyl-butane is the major product. Because why 2,3-dimethyl-butane is the major product? If we compare, actually here this 2,3-dimethyl-butane will have more alkyl group, which making it more stable. If we in the early we change the carbon cation to here, this only have one alkyl group, which the product will become 2,3-dimethyl-butane. Actually, it is a minor product because it only have one alkyl group. Since we follow the success rule, we need to change the tertiary carbon cation to a more alkyl group, which we change to the atom that has more alkyl group. So in the previous step, OSO3H will grab a proton, which is H, and leading to a regeneration of H2SO4. Why we didn't write H2SO4 here? Because H2SO4 only as a base for the reaction to occur. So this is the final product and the reaction is done. I think that's all from me. Thank you.